Hey everyone, it is 11 p.m. the night before this lesson, and I'm finally getting around to making this video. I've been out doing my own class. It's been crazy. So now I have a nice cup of tea, and I'm ready to go here. Now we gotta finish actually section 6.1. So let's do that. So you got this document over here. Boom, looks like this. Okay, we've already gone through most of it, and at the bottom of the first page, though, I left out something here. I wanted to produce these graphs in a graphing calculator. So we haven't done that before. So let me load up my graphing calculator. Hey, there it is on my table. See, look, what? There's my hand flying over. Isn't that crazy? So we're going to try using the document camera here and the calculator in order to graph these different functions. First function that we wanted to graph is f of x equals 3x minus 1. So here's what we do. On your calculator, you can click on y equals. Click. Hey, look at that. I can now enter a function. Well, 3x, there's the x button right there, minus 1. Okay, now I can click on the top right, which says graph. Look, it's a line. Isn't that exciting? Now I'm trying to find the axes, and I'm having a little trouble. So I'm going to just work on the zoom here. Okay, I can just click on all sorts of different options for zooming, and one of them is zoom standard. That's the 6th one. Okay, and that's a nice little zoom. It actually gives you all the numbers from x equals negative 10 to x equals positive 10, y equals negative 10 to y equals positive 10. Okay, if I wanted to change the zoom, I could always do that with some of these zoom options. I'll let you figure that out on your own. It's good actually just to play with that at first. Okay, so there's the graph. Look, it's a line. Isn't that exciting? Why don't you try the second one right now? So I'd like you to pause the video and try typing in this function into your calculator and taking a look at the graph. So try stumbling around with that a little bit and then unpause in one moment. Go. Okay, welcome back. Here I'm starting to type in the function right there. Hey, look, this is 2x squared. This is how I'm going to write an exponent. So anyway, this is y equals 2x squared plus 4x plus 2. So plus 4x plus 2. Okay, let's take a look at the graph. Hey, there it is. You know, I kind of want to zoom in a little bit and play with that. So in this case, what I'm going to do is click on this button right here. It says window. Hey, look. It tells me the x minimum and the y and the x maximum. The x minimum and the x maximum. So we're just going to play with those kind of features. I'll go from negative, say, 5 to positive 3 for the x and negative 2 to positive 10 for the y, just for fun. Okay, if I alter that, it gives me a better kind of zoom in. Oh, isn't that fun? Okay, so now please record that you're able to do the final question of homework from this page. So in this section, I hadn't assigned page 383, question number 3. So once again, that's, hey look, it's paper. Isn't this exciting? Page 383, number 3. So when I give you time to work here later in the class, when I give you time later in the class, you can work on that question now. Okay, let's actually move on to section number 2. Scrolling. Okay, so there's 2 words that we need to learn here. Leading coefficient and constant term. Okay, so a leading coefficient and a constant term. Well, I'm going to take a moment to write out just some random polynomial function here on the scrap paper. Let's see. Y equals 4x squared plus 2x minus 3. I don't know. It's just some random function. And let me show you what the leading coefficient is and the constant term. The leading coefficient is this. Okay, that's the leading coefficient. The leading coefficient is the number in front of the x with the greatest exponent. It's the number of the x with the greatest exponent. We call that number the coefficient. Hence it's the coefficient, and leading, well, because it's the coefficient of the leading term. This is what we call the constant term. Okay? The constant term in this case is -3. It's the numerical term with no x's attached. Okay, so it's just kind of floating there on its own. Notice there's no x, so it's not 3x squared or 3x to the power of 3. Just a -3 all by itself. Okay, lonesome on the end. That's the constant term. Okay, now these will be important to us for a couple reasons. The constant term is important because it is the y-intercept. The constant term always provides us with a y-intercept. Slide that over. There we go. The leading coefficient is only important in terms of if it's positive or negative. Okay, now the effect that it will have, we will see that shortly. So I'm going to leave that as a little mystery. Okay, let's get back to this. All right, so for today, what we're going to do is take a look at some examples of using technology to graph a few graphs. And we're going to take a moment to talk about all of the different characteristics of these functions. Okay, so for example, f of x equals 3. We can graph that graph, and we can make some declarations. How many x-intercepts are there? What is the y-intercept? What's the domain? What's the range? How many turning points are there? And ultimately, what's the end behavior? What happens on the far extremes? Okay, so let's take a moment to use technology to graph f of x equals 3. I'll take the lead on this one. All right, so I'll go into my y equals. I'm going to clear out the first line. I'll have y equals 3. All right, that's it. So here's the graph. Yeah, pretty boring. It's a flat line, okay? It's a horizontal line, and that's it. There's not really much to it. So what do we know about its characteristics? Well, number of x-intercepts, 0. The y-intercept, well, that's at 3. Hey, 3 is a constant term, and 3 is the y-intercept. Wow. The domain, well, the domain is all real numbers. All real numbers. So you have a few ways of writing that. Let me show you on paper. If I wanted to write the domain in this case, I could write the words all real numbers. Or there's a nice little symbol that goes like that. Okay. Remember, the domain is just the set of all the x values. And if you look at the graph, well, there's no restrictions. All the x values to the left exist. In this graph, all the x values to the right exist. There are infinitely many x values. But what about the range? So when dealing with the range, we're asking what are all the y values? Well, the range here is pretty basic. It's just y equals 3. Number of turning points, well, there's 0. It never turns. And the end behavior, well, it's not very exciting at all with the constant function. It just stays flat, right? So it stays constant into quadrant 2 and quadrant 1. Would be one way of writing that. Okay? I mean, you could say that a line extends from quadrant 2 to quadrant 1. Yeah, it's pretty boring stuff. Oops, you can't see what I've written there. Hey, there we go. Isn't this document camera stuff so much fun? Okay, I'd like you to take the time now to try the other 3 functions that are there. So graph the function. Tell me how many x-intercepts. What is the y-intercept? What's the domain, the range, the number of turning points, and the end behavior for these 4 different functions, or the 3 remaining functions there. Okay? So pause the video now, and it's going to take you a few minutes here to do all 3 of those. Good luck. Okay, welcome back. Really quickly, here are the answers. For negative 3x plus 4, it has one x-intercept. The y-intercept is 4, the constant term. The domain is all real numbers. The range, all real numbers. This is a line, right? It goes on forever in all directions. Number of turning points, 0. And the end behavior, well, this goes off to quadrant 2 and quadrant 4. So up here in quadrant 2 and down here in quadrant 4. And for the picture, well, you can copy that out of your graphing calculator, hopefully. Next, we have this parabola, right? So it should be a nice little parabola. It should be pointed downward. How many x-intercepts are there? Let's see. There are 2 x-intercepts, I believe, unless I got that wrong. The y-intercept is at 4. The domain is all real numbers. And the range, boy, if only I could find the y value of the vertex. I'm going to leave that for a future lesson. So we're going to wait to see how to find the range in this case. It does have a turning point at that vertex, so there is one turning point. And the end behavior is that it goes down here into quadrant 3 and down here into quadrant 4. And last but not least, we have the cubic function. Okay, so this polynomial's got 4 terms. Number of x-intercepts, well, let me see that here by graphing it. So we're going to do that real quick. Give me a sec. I'll hit pause. Okay, welcome back. Sorry about that. Now I've actually gone and typed it in. So here it is. Boom, ba ba ba. And I hit graph, and I played around with the window settings a little bit so I could zoom in on my function. There it is. This actually has only one x-intercept, which is interesting, even though it's a polynomial of degree 3. And it has no turning points in this case, which is also interesting. So it could have a few more turning points if it wanted to. It just decided to keep rising the whole time. Okay, for the domain and range, those are both all real numbers. And the end behaviors, well, you can see that here. It's going up into Q1, quadrant 1, and down into quadrant 3. Okay, now, notice in this example, we just asked how many x-intercepts. We didn't even tell you where it was. Just like in the last example with the quadratic, we didn't tell you where the vertex was. Oh man, such limitations. Well, we're actually going to be able to fill that gap when I come back tomorrow. So for right now, it's a grand mystery for you. I'd like you to get some homework done then. A couple things to do here, and let me just zoom in on it. Boom, there you go. All right, I want you to read example 2 on page 388. This is an excellent example. It's really well done. Read the key ideas. That's just the summary of this section on page 392. And then on page 393, we've got questions 1 to 3, 6, 7, and 13. I really hope you enjoyed this first video, making it with all these different new features. It's a little bit of an experiment. Hopefully it turned out. I almost finished my tea in this time. And now I'm going to sleep. Hope you have a great day. We'll see you again tomorrow. Here's the homework again. Bye for now.